You are listening to EE Times On Air, and this is EE Times Current. I'm Eric Singer. Today's episode is brought to you by Siemens EDA. Our guest today is Sathishkumar Balasubramanian. Satish currently leads the product management and marketing organization for the custom IC verification division at Siemens. He's been in the industry for over 20 years, and when you look at his career, you can see that he's been very much focused on the idea of bringing value to the overall semiconductor ecosystem. He's got an impressive track record in product portfolio growth and expansion of market share and revenue through this relentless focus he has on data-based execution and the kind of thought leadership you're about to hear in our conversation. Prior to Siemens, Satish held various product management, strategic business development, and corporate development roles for Cadence Design Systems and Synopsys. Satish received his BS in Electronics and Communication from the University of Madras, and then got his Master's of Science in Computer Engineering from the University of Alabama here in the U.S., and then went on to get his MBA from UC Berkeley's Haas School of Business. Satish, let's go back even before your education. Tell us how you first got into the semiconductor industry. Were you already interested in tech from an early age?
Wow. Okay, I gotta date myself. So I was a I was a Trekkie. So I grew up watching Star Wars and Star Trek. My dad was big into Star Wars. He introduced me to it. So I grew up in India for my high school schooling days. This was during the late 90s where we were all building our own PCs. The PC revolution was happening with the CPUs, all the gigahertz and 1 gigahertz. So I was into building PCs myself, and that's how I got into the tech sector, did my engineering, and then, I wanted to understand what goes into PCs, which is essentially semiconductor chips. And that's one of the motivations I wanted to learn more. So I kind of gotten into my undergrad and grad into VLSI. And that's how I kind of got into this whole semiconductor industry space. And you know what? It's been a great ride so far. And we are still in an infancy. We are doing a lot more things right now. That's going to even supercharge further the innovations that's going to happen in this industry.
I can very much identify with some parts of your origin story, and I think a lot of tech folks of our generation do. So many of us were sci-fi fans and PC builders, but kids these days are not really building their own systems like we were. And I don't know, is that a tiny piece of this big problem we have? One of the trends that we're seeing in the semiconductor industry is a lack of young engineers coming up. There aren't enough skilled people to fill the gaps in the workforce that we have. So before we get into the main topic of today, which is AI EDA tools, I'd love to talk about that trend as well as other trends that you see currently in the industry.
That's a great observation, Eric. Yeah, we do see that. There's a lack of workforce and training, even the intuition from the younger generations on getting their hands dirty in doing the things that we did when we were growing up. But in general, the trends that I see in the industry is this. We see that everywhere there is smart this, smart everything, sensors. So you could see that chips or semiconductors everywhere. It's interesting that you're talking about semiconductor because I work in an industry called Electronic Design Automation, EDA. And whenever I used to go and explain myself to someone I meet, even in US sometimes, or even in India or Europe, or in my relatives, I used to say, it used to be a tough thing to explain what I'm actually doing, which is essentially building software for semiconductor design. But COVID happened, right? And then I go into my hometown, which is in South India, for a family wedding or something. And someone asks me, what are you doing? I said, I am into semiconductor and I'm doing something related to semiconductor. It's like, oh, chips. I know. So you're working in the chip industry. And this is someone, a middle-aged person, totally out of tech, but they all know about chip, right? So what I'm trying to get at is, the awareness of semiconductors increased quite a bit. That's mainly because with what's happening in the world, with COVID and other things, chips are everywhere. So the design volume is ramping up. The complexity of semiconductor designs are exponentially increasing in terms of functionality and the number of gates that we are cramming into each of the chips. And The costs essentially are increasing, time to market is reducing. So essentially, we're coming up with use cases where you need to get a chip out within the 6 months. If you don't, someone else does, right? So you lose the market. And the last but most important thing is the system is not actually graduating enough engineers who are into the semi industry. So this existing talent shortfall, we are actually seeing it right now, even among my own company or my own industry over here. The workforce is getting aged and retiring slowly, or they're seeking other careers. So we are at the cusp of where there's a huge demand that's needed, but we also see a big shortfall in terms of the workforce management as well. So that's the trend I'm seeing where we have huge demand, but we really need to do a lot more to get people ready to actually cater to the demand.
Yeah, that huge demand and that heightened visibility among members of the general public. The convergence of that demand you mentioned, but also a demand for higher reliability. Think about automotive manufacturers asking for these very high sigma or even a zero failure rate with traditional tools that seems pretty much undoable. So we're turning to AI tools to respond to those demands. How do we evaluate those tools and cut through the hype to understand what's really possible now and what might be moving forward?
Yeah, definitely. Yeah. So to answer your question, AI is it a hype or a real thing? I would say, you got to look deep into each of the offerings and kind of figure out whether it's a hype or a real thing. We do see a lot of fluff happening in this industry, but with Siemens and mainly with Siemens EDA, we got some real production worthy AI enabled solutions. So the way we look at AI within Siemens EDA is actually threefold, right? Kind of three axes, you can say. One is on the technology. Essentially, what we mean is we embed the AI into the tools to actually deliver error free designs, right? That's one thing within the technology. Then we use AI to actually provide in improved process management from start to finish. Think about the digital twin methodology, right? Or shift left, where you essentially are designing a chip or designing a factory floor. You need to be able to not wait until you put your foundation in or actually get your chip fabbed out, but you need to do everything you need to do upfront in a virtual environment, which we call the digital twin, to improve the processes and automate it. So that's another way where we are looking at in terms of AI, in terms of enablement. And the third is the platform, right? We got to have an AI enabled platform to actually make better and faster and more informed decisions. So there are three things to it: tools, processes, and platform. And we actually within Siemens EDA have technologies and production worthy technologies actually across all these three different axes we see in terms of AI enabled solutions.
We talk about applications like automotive with those very, very strict requirements. And I'd like to ask you, what are some of the key attributes for those AI enabled tools in order to meet those requirements?
Yeah, I think that's one of the key things, right? With automotive or any kind of a design or chip that goes into what we call mission critical. I would say an industry or an application. For example, automotive is one, right? Space application is one. Going industry, right? Industrial application is one. Wherein which you really need to make sure that whatever you do with AI to come to a certain solution is accurate. So the way we look at it is there are like five key, I would say, there are like different attributes that I would say that's needed for a software or an EDA software with AI to cater to these industries. Number one thing is verifiability, right? We want to make sure that the AI model we use or we create on the fly is correct. The second one is how accurate or perfect is that AI model. The third thing is the AI model or the AI approach should work on everything, generality, right? How general it is. And the fourth thing is robustness. This is where you say, okay, I'm going to bet my design schedule on it and it's going to work day in and day out. And the last most important thing is also the usability, right? Can it work out of the box or I need to hire some PhDs to make it work? Okay. So five things: verifiability, accuracy, generality, robustness, and usability. If we can enable AI, if we have the AI enabled solutions that can satisfy these five requirements, then you got a blockbuster software that's really going to help the productivity of the engineers.
How does Siemens think about building the things you're describing? What are the foundations of how you are approaching building those AI tools?
So first of all, we need to identify a problem, right? So and we need to identify a problem that really requires an improvement in terms of either accuracy or doing something that's not previously done before in a more efficient way. And then once we identify a problem, what we call it the different levels of AI in terms of software development. You all know about autonomous way of doing it, right? So I'm kind of giving you the same analogy, right? Level 0, level 1, level 2, level 3, and level 4. So in a similar way, I'm kind of giving you what we call it as level 0 is where there's no AI, right? It's a regular software, just gives you the right answer, but by running all the test cases or the traditional brute force way of certain things, more compute intensive, right? That's what people use most of the time. Most of the tools are like that. No AI, which is traditional EDA software. Level 1 is what we call it a partially reliable AI. So what we do is you take a very good foundation and then say, okay, with partial reliable AI, how can we speed up, right? We can give a big speed up where we definitely give you performance, but then we do something sometimes right or sometimes wrong, right? It's a pretty nice prototype, but I would say I won't bet my production run on this partially reliable AI. Okay, not useful yet. Yeah, so it's very easy to get this to this stage. This is more of a prototype stage, right? And I've seen a lot of tools that are available in the market are in this stage. That this is where we call it a hype, right? And we come to a next level, level 2, where we have partially reliable AI. But the most important thing is you got to make sure that you have an accuracy aware self verification. What this means is you need to have the self verification built in so that the software can tell when it is actually having the right answer or the wrong answer based on certain criteria, right? But in this case, tool can't solve it automatically, so we need to provide that criteria all the time. So this is where we are kind of slowly getting into a decent kind of a product quality of AI software. And then we go into the next stage, we call it level 3, which we call adaptive and accuracy aware AI with self verification. In this case, it's the same as the level 2, but it meets accuracy criteria, but it does everything automatically. So you don't need any user input to provide a say, hey, can you go check this and this, that? It's everything is self-contained. It runs it, it goes, checks it, and makes sure that it always is correct. But in this case, there is still a certain corner cases that might not be covered. I would say level 3 is where I've seen some of the most advanced tools from competitors are there, where it's useful, but some of the corner cases it doesn't really work, right? But it's useful with great support. Level 4 is what we call the holy grail of AI tools, which is like fully reliable accuracy of our AI with self verification. This means that, for example, Solido high sigma verification verifier that we just released last year. This is a production ready dependable, where in which it's out of the box, it runs, it self verifies, self checks. If it doesn't converge or doesn't meet a certain criteria for what is designed, it goes back and redoes the modeling again. And again, does this over and over again with the design of experiments until you get to the right answer. So this is where it's very self-automated, out of the box, production hardened, and it just works. Getting from level 0 to level 2 is very, I would say, in terms of man months, I would say it's kind of not very short time, probably within a year you can get that. But getting from level 2 to level 4, it takes time. That's where the real expertise comes in. That's where the amount of exposure your software gets into real world EDA problems helps it harden. And with Solido, since from 2005 we've been doing it, since 2010 we are kind of in level 3, and almost 2015 onwards we are at level 4 for the applications we have built in, which means that we have a tool that covers all the corner cases. It works out of the box, it's self-verifiable, and always gives you the right answer. We have several solutions that are AI enabled. For example, we start all the way from our prototyping solutions or the emulation, right?
Sure.
So we have in emulation and prototyping, we have a Veloce platform that actually uses AI to actually reduce the compile time upfront, 50% reduction in the compile time.
Whoa.
That's a huge, I would say, savings that we do. And we have a lot of ways of doing that. We learn from previous compile, we learn it on the fly, and we actually increase the amount of time it takes in the hardware simulation to do it. The second one is going to be on the functional verification, which is a Questa platform. What we do is we actually increase the verification coverage, and verification coverage is essentially where you have a design, you need to make sure that I verify all the different corner cases that can ever happen for that particular design. With AI, we are able to use different techniques to actually reduce the time that's spent to get almost 100% coverage, almost up to 3x reduction in time. Siemens is one of the leaders in terms of AI-enabled EDA solutions. We in 2017 we acquired a company, Solido Design Automation, and it's an interesting company, Solido Design Automation, in the sense that they were one of the first companies to actually use machine learning and AI to solve real world EDA problems. In 2005 to 2007, they came up with their first product called High Sigma Monte Carlo, Solido High Sigma Monte Carlo. And you all know about Monte Carlo simulation, right? If you want to run like Six Sigma, you got to run close to 1 billion samples and so forth. But it's essentially not feasible for people to run that many number of simulations to achieve the confidence level of that High Sigma. And this is especially very critical for automotive and other key designs that's going into mission critical computing. So what Solido came up with is a Solido High Sigma Monte Carlo. And this was a solution that used AI modeling in which we were able to give the same confidence of 5 to 6 sigma of brute force, but with far lesser simulations. For example, with this particular product and using the AI techniques, they were able to bring same accuracy as brute force Monte Carlo, and they were able to get that in less than 10,000 simulations. So if you think about you running 1 million plus or more than 1 million simulation for a certain sigma, you essentially bring it down all the way to 10,000 simulations or even less than 10,000 simulations. That is almost 100x improvement. So that's been the foray of Siemens EDA into AI-enabled solutions, and since then, the Solido team has come up with almost close to 8 to 9 different applications using AI, and which essentially really solves the problem. So the question you asked before was, is AI a hype or something real? It is real as long as you know the problem space and how to use those techniques to solve the problem that really matters to an engineer. To further answer your question, I think I want to add up on that is not just Solido, right? So we got several products within Siemens EDA. So you all know about Caliber, right? Caliber is the foundation or the sign off for all the ICs that gets out in the world. And with Caliber, we've actually used AI to figure out, a lot of different things like how can you do an optimized resource prediction before you start a run so that, you get to the finish line faster. The second thing is in the lithography, right? In Caliber, semi-caliber litho tools, we use machine learning techniques to actually figure out, for example, where is the hotspot? How can you detect the hotspot in a much more faster way rather than spending too much time in doing it in the traditional way? So the way we are looking at AI within Siemens is how can you use AI and ML techniques to speed up a certain process or a flow or a certain thing, certain function that the customer is using or the designer is using to achieve a certain task. The second thing is how can we come up with a solution that customers never run before? For example, the customer gives up saying that, okay, I can't run a billion samples, so I'm going to just have a huge margin in my design, right? That's a waste of space in terms of PPA and so forth. In this case, we kind of say, hey, we have a solution actually to achieve that. So you don't need to have those margins, which means that you have a design much more optimized. You get a lot more devices per wafer, and it helps you in terms of your margins and the number of chips that gets out the door. So it's really a game changing way we are looking at AI enabled solutions, which is more practical and which is usable and repeatable and verifiable.
In the popular culture, for people out on the streets, what everybody is talking about in AI is not chip design. That's not on people's radar, even though chips certainly have become more visible. What the average person out there in the world who's not involved in our industry is aware of when it comes to AI is generative AI, large language models, things like that have really entered the awareness of the everyday person. Do you see generative AI playing a role in chip making and packaging methodology? Is there a place for that piece of AI?
I would say absolutely. I think we need to review it in a different way for generative AI. Definitely, there's a huge value that's still being, I think we are in an infancy stage right now.
Yeah.
And you're right, AI-enabled solution is the foundation for it. But think about this, the way we are looking at generative AI, right? You're talking about ChatGPT, which is fine. So large LLMs and so forth. When we look at any of our customers or any kind of big semi companies, they've been doing, for example, hundreds of chips, hundreds of designs for the last 10, 20 years. Okay, let's take, for example, any big semiconductor company or the big GPU company. That's one of the number one company or any company for that matter. The beauty of Gen AI is you have this enormous amount of data and knowledge that's being there within each of these companies. Okay. But what happens is when you start a new project or a new design, you start from fresh most of the time, right?
Mm-hmm.
And the only thing that might link is some kind of a very vague knowledge of certain scripts or, so the people that are doing it, they've done it before, and they might be the only link to what has been done before. With generative AI, what's the very most benefit we get is this generative AI can tap into these huge volumes of data resource that resides within each big divisions or each design companies, and actually help them in multiple ways. One thing is help them in designing, in getting the best practices out for the next design in an automated way. That's one thing.
Mm-hmm.
The second thing is if you're doing something that you already know you encountered an issue before in your previous design, it's going to easily be smart enough to tell you don't do this way. We have already done it, it didn't work, right?
Mm-hmm.
And the third thing is going to be, we talked about the workforce problem. You don't need to be having experienced engineers or designers uh, being being there to train your incoming workforce or less experienced person or a person in a different discipline of what they need to do, right?
Mm.
And they can use this generative AI. I'm coining a term generative AI, which is essentially what I'm talking about is LLMs and so forth, right?
Yeah.
We can use this generative AI methodology to actually use that inbuilt knowledge that each of the companies have to actually help train the next generation of engineers or other engineers in a much more faster and more efficient way. Think about having like a more experienced person sitting next to a less experienced person, right? That's what I view the generative AI platform as.
Yeah.
So that's those are the three things that's going to really be driving in terms of generative AI platform. But the key attribute that we need to have for these generative AI platform is interesting because within the design community, within semiconductor industry, data is very sacred, right? No one wants to share data. So the chat GPT, you might hear about chat GPT going and, taking about YouTube and everything. It's not like a very simple thing, right? Because we don't want to share the data. The customers don't want to share the data.
Yeah.
So we want to make sure that the data that the customer has all the control of what he wants to do and where it wants to reside on-prem or on the cloud. But we need to have a generative AI platform that actually respects the data integrity and the data ownership. The second thing is anything that we do in generative AI platform, as you know, it needs to be open in the sense it can't be just working with one kind of a methodology or one kind of an EDA vendor. It needs to be having the bells and whistles so that it can hook up to all different methodologies and different EDA vendor tools. So that's the reality, right? So that you take the maximum benefit out of the generative AI platform. And there are different applications we can build on it. So I've seen customers on generative AI platform. Everyone is talking about generative AI, and I'm starting to invest and look into it. And the most important, easy, obvious thing people do is they want to do a chatbot within their own company.
Mhm.
And for example, they can say, hey, I'm in this process. What's the spacing rules for this particular process, right? Instead of you going and reading a manual or a text file, if you have a generative AI platform that's actually uses different ways of building the model, either an LLM or a RAG framework or any kind of a framework, you start injecting it with data that you already have, then it's going to be a natural language processing way of interacting, right? A designer is saying, hey, I need to know the spacing between these two layers, right? And the platform should be able to give that answer immediately to the designer. That's a huge productivity gain. I'm just giving you a very simple example, but this can be extended to throughout the design and verification methodology for a semiconductor chip design. So those are the things that I see generative AI capable of doing right now. And there are a lot of other things that could be done in the sense we are still in a very infancy stages of can I create a design or can I start writing my own code, right? For example, right now in software industry, they can write software code, right? There's a huge noise about, you don't need this many software engineers because, generative AI can write the code, right? I mean, you've been hearing it. We are not there yet on the hardware side of things, but, it's a matter of time before generative AI platform becomes smart enough with more interactions and more training that it should be able to help even the hardware designers, people doing semiconductor design, being able to take advantage of creating design from scratch to a certain stage where from that point a designer can take it and complete it.
I love the way you just brought this conversation right back to where we started, how you got into this industry building your own PCs, and how young people today are not really doing that. But what they are doing is interacting with LLMs and generative AI. And I wonder if that is the analog for their generation. And that's how they might break into the semiconductor industry.
Yeah, I think that's a great way for you to think, right? The interesting way, I will give you another analogy, right? I have a son who's learning, he's doing some school projects, right? And he's working and he needed to learn Python. Okay. And he had never done Python. He'd done Scratch, he'd done Java, but he never knew about Python. When I was growing up, if I have to learn a language, right, take up a book, read the syntax, read how it works, start typing, make mistakes, correct. It's going to take me a month, right, 2 months, 3 months to be at least decent good at it, to get something done.
Yeah.
Surprisingly, he uses ChatGPT, right? He knows he's doing something with the data manipulation, a big data manipulation with a huge, big Excel. So he just says, hey, I want to do this, I want to do that. How can I do this? And in Python. And the entire class and the entire software is essentially written for him. And all he does is prompt engineering. Essentially, he goes there, he looks at it, oh, he puts in an input, oh, that's not the output, we need to change this, change that. But within a week, he got a program that's ready, right? And that's the beauty I'm talking about of generative AI, right? So you're right. I think we view it in a different way. I think the way the new workforce is going to learn is not by reading books, but by really looking at data and interacting with data and understanding how a certain things work. Right? It's much more of a query based learning or a prompt based learning than the way we did the learning on our side. So yeah, you're right. It's a beautiful platform. It's a beautiful technology where we can learn, and even inexperienced users can learn, right? And the beauty about this platform is generative AI is there's no more silos anymore. The knowledge is being shared
Mm.
within an organization or within a division in a way that it's not siloed anymore. So if I have to learn certain things in the software stack of some of the drivers that's going to be interacting with my hardware, I can do it in a way that's easier for me to understand. And vice versa on the software side of things as well, when they want to learn something about the hardware. So yeah, the opportunity is limitless, but I like to mention that we are just scratching the surface of generative AI, but we are doing the right direction of getting the chatbots and all the low hanging fruits that need to happen is happening right now. But I believe in another 5 or 10 years we'll be surprised with the amount of progress this technology has made or gotten embedded within the semiconductor ecosystem.
It really is an incredible time to be a part of this industry and seeing what's happening already and what's to come. Satish, I can't thank you enough for sharing all of your knowledge and your insights about AI in EDA in general, and for helping us understand what the pretty revolutionary capabilities are, particularly in those three products in Siemens EDA portfolio. We really appreciate you coming on the show today and sharing all of this with us.
Thanks, Eric. Pleasure is mine. Thank you for the opportunity.
That brings another episode of EE Times Current to its end. Thank you for listening, and thanks again to our guest, Sathishkumar Balasubramanian from Siemens EDA, for joining us. EE Times Current is available through the major podcast platforms, but if you get to us at our website at eetimes.com, you'll find a transcript along with direct links to the other stories we've mentioned and other resources. EE Times Current is produced by EE Times. It was engineered by Taylor Marvin at Coop Studios. I'm Eric Singer. Thanks for listening.